Alright, the purpose of this video is to review the 4 parent graphs. The first parent graph we're going to look at is the absolute value. So you need to memorize the pattern, the parent points, as I like to call them. So we've got, when you plug in -2, you're going to get +2, -1, 1. The absolute value of 0 is 0. The absolute value of 1 is 1. And the absolute value of 2 is 2. So when we graph that, -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. This is the basic pattern for the parent graph of absolute value. Next, we have the quadratic. Here again, we're going to use the same x values. -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So the basic parent pattern for a quadratic, y equals x squared, -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. You need to learn these patterns. They're all going to come back to this basic shape. Alright, next we have the cube root. The square root. Y equals the square root of x. The points we're going to use are 0, 1, and 4 because they're perfect squares. Notice we don't have any negatives because you cannot take the square root of a negative number. It's imaginary and you can't graph that on our coordinate plane. Alright, so the square root of 0 is 0, the square root of 1 is 1, and the square root of 4 is 2. So our square root pattern, 0, 0, 1, 1, and 4, 2. Notice the curve. And finally, now we have the cube root. So the cube root of -8 is -2. Cube root of -1 is -1. The cube root of 0 is 0. The cube root of 1 is 1. And the cube root of 2 is 2. Alright, we're going to fit this on our graph as best as we can. So -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. Alright, this is like a stretched out curve. Make it as smooth as possible. That's our cube root pattern. Okay, so let's put the transformations in there. Let's look at an absolute value graph. Alright, first of all, identify the parent graph. In this case, is the absolute value. Look at the parent points. -2, -1, 0, 1, and 2. Alright. And what I like to do is figure out the move that this is going to make, where the new vertex is going to be. So this thing is going to move right 3, up 1. So I'm going to graph that first, so 3, 1. And then I'm going to move my parent points. Now it's counting now. It's not coordinates anymore. I'm counting from my new vertex. So I got 2, 1, 0, 1, and 2. I'm counting from my new vertex. So I'm going to go left 2, up 2, left 1, up 1, right 2, up 2, right 1, up 1. And my 0 is my new vertex. That's one way you can do this. So move the vertex and then count the parent points. All right, another option that you have, you can graph the parent graph first. So here again, I'm going to use my parent points. Graph my parent graph. And continue the pattern all the way through. Alright, now look at the transformation. This graph's still going to move right 3, up 1. So that's what I'm going to do with all my points. I'm going to move all my points right 3, up 1. Right 3, up 1. And I continue that from my entire graph. See, in both cases we get the exact same answer, just a preference on how you choose to graph it. Alright, let's look at a quadratic. Here again, I like to figure out my transformation first, my new vertex. So this is going to go left 3, down 2. Alright, my parent points, negative 2, 0, negative 1, 0, 1, and 2. So 4, 1, 0, 1, and 4. Alright, I'm going to graph my vertex, negative 3, negative 2. And then I'm going to count my parent points. So it's not coordinates anymore, it's spaces. I'm counting the distance to get that pattern. So left 2, up 4. Left 1, up 1. Right 1, 0, 0 is my vertex. Right 1, up 1. And right 2, up 4. Alright, here again, if you prefer, you can graph the original parent graph first, and then transform your points. Slide them left, right, up, and down. So if I'm going to go back to graph the original graph, my parent points, alright, so now my vertex is negative 3, negative 2. That means I'm going left 3, down 2. And I'm going to use the pink to show how I'm moving my point. So I'm going left 3, down 2. This point, left 3, down 2. Left 3, down 2. On the positive side, same thing. Left 3, down 2. Left 3, and down 2. So you see how we get the same graph, whether we graph it from move the vertex first and then the parent graph, or graph the parent point and then move to the new vertex. Alright, a square root graph. Alright, remember the parent points from a square root graph were 0, 1, and 4. So that makes it 0, 1, and 2 for my y values. Alright, this one's going to move right 1, down 3. I'm a vertex first person, so I'm going to go right, I'm going to go 1, negative 3, and then I'm going to count my parent points. So 0, 0 is my vertex, right 1, up 1, right 4, up 2. So here's my graph. Here again, let me demonstrate how you can graph it from the parent point. From the parent graph the parent graph first. So 0, 0, 1, 1, 4, 2, and now I'm going to use my transformation. So I'm going to go right 1 and down 3. So I'm moving every point right 1, down 3. So there's my new point. Down 3. Here again, right 1, down 3. So you see we get the exact same graph, just a matter of preference in graphing. Have a little bit of a choice. Alright, let's do a cube root. Alright, the parent points for a cube root. Negative 8, negative 1, 0, 1, and 8. Why do we pick these? Because they're perfect cubes. Alright, so the points are negative 2, negative 1, 0, 1, and 2. Alright, how are we going to move? What's my new vertex? It's going to move left 2, up 1. So left 2, up 1. Alright, we're going to fit the points as best as we can on here. So negative 8. Now I'm counting from this new vertex when I count that negative 8. Down 2. About right there. Alright, left 1, down 1. 0, 0. Right 1, up 1. And then right 8. Up 2. So there's my graph. Try to make a smooth, nice smooth curve. There's my cube root, stretched out S. Alright, here again, we can graph the parent graph first. So 0, 0, negative 1, negative 1, negative 8, negative 2, 1, 1, 8, 2. So here's my parent graph. Now we're going to transform it. So that means all of our points are going to move left 2, up 1. So left 2, up 1, left 2, up 1, left 2, up 1, left 2, up 1. So see here again, you get the same graph, whether you graph the parent graph first and then do the transformations, or do the transformation and you do vertex first and then use your parent pattern to complete the graph. It's very important, however, that you know these 4 parent graphs. So if you need them again, go back and watch the video again.